Alright, let's try this again. I started this the first time and then Patriots fumbled it right as I started and I couldn't even have words to say about that. Okay. So triangles is what we're moving on to. Since we've done points and lines, now we need to make shapes. So we start with triangles, the funniest of all the shapes. So first thing we look at, nice and easy, nothing new here. How do we name triangles? So if we look at their sides, there are three types. Equilateral, which means all the sides are the same. Whoops. Isosceles means at least two sides are the same. It's funny that they write it like that, because if we say at least two, that means that this one over here is also going to be isosceles, because at least two of these sides are the same. In fact, all three are the same. And then scalene, no one likes scalene triangles. It's like the Jabba the Hutt of triangles over here. No congruent sides. They're all different. The only thing we need to really notice here are what the little marks mean. So these little marks indicate that this, and this all have the same length. So even if we don't know what the number is, we know they're the same. It also means that if we were on one problem here, like this was problem 1, and we had another Jabba triangle over here, and this one was marked with a 1. Generally speaking, we can say that this length is the same as this length. Okay? But it has to be in the same problem. I don't want to see, because we're going to come over here, and we're going to get to like question 8, and you'll be like, oh, this has one little red mark on it, and so did this one back here. They must be the same. No, it doesn't quite work that way. Okay? 2 marks has nothing to do with it being isosceles. I don't know why they did it like that. They could have made this example easier if they had just made 1 mark and 1 mark to show that this side is the same as that. The reason why we'd use different ones is so we can show that, like say this was also part of question 1, which might be what they were going for, is to say that these 2 lengths are the same, but they are different from these lengths over here, which is why these are marked with 1 little hash mark or tick mark, whatever you want to call it, and these are marked with 2. Okay, so anything that had 2 little marks on it, we know would be the same length. And Scalene gets no marks because no one likes him. We'll give him some hands though. I think Jabba had hands. Kind of creepy hands, but whatever. Okay. That looks pretty funny. You can give him some eyebrows too. Some big blue eyes. And some snarly teeth. Okay. Going by angles. So up here, this is just looking at sides. This is looking at angles. So we start with acute triangle, where all the sides are acute. So this is our acute triangle. Look how cute it is. It's got little cuteness rays coming off of it. Equal angle, this triangle. All 3 angles are congruent, and they're all acute, which means, I don't know why they didn't put the number here, this has to be 60 and 60 and 60 to make it add up to 180. Alright, then you have your smart guy triangle over here, because he's always right. Get it? No? Whatever. Alright, and last one, obtuse triangle. This is upside down Jabba triangle. He's been partying. Still has no friends. Everyone looks down on him because he's upside down and obtuse. But he has one obtuse angle, which is an angle greater than 90. One thing you have to be careful about here, and I know none of you would make this mistake, but I'm sure someone has, and it's a little silly, or maybe you never even thought about it, is on any triangle, there will always be at least 2 acute angles on every single one. It's impossible to draw a triangle with more than one obtuse angle, or one right angle and one obtuse angle. It doesn't work out because all you have is 180 degrees. So as soon as you pick one angle that's 90 or more, you're left with 90 degrees at most. Yes? And since this needs to be split up into 2 separate angles, I mean, this could only be 89 and 1, which is still acute. Even if it was 89.999 and 0.001, this is still acute, and so is this. So on any triangle you ever see, there will be at least 2 acute angles. So what it comes down to is, what is the third angle? Okay? Is that last one acute? Then we know it's acute. Is that last one a right angle? Then it's a right triangle. Is that last one obtuse? Then it's a Java obtuse triangle. Okay? I just realized that if you haven't seen Star Wars, that Java reference might not actually make any sense. So hold on, I got something for this. Patriots are winning, by the way, so it's all good. Houston didn't win. Oh, I can't find a whole Jabba the Hutt picture here. Hold on. Wait for it. This is totally gonna be worth it. Probably not, but look, he's a triangle. He's triangular in fashion. Look at 1, 2, and 3. Although he's kind of acute here, so whatever. Okay, so that's how we classify triangles. We can move on and practice now. Alright, apply vocabulary to answer the question. And you should pause and do this yourself, because you should be able to do this. You should have been able to do this before I said anything. So, pause it right now. Okay. Alright, in triangle JKL. So let's draw a triangle JKL. Bam, there it is. This is J, K, and L. And then I'm going to erase all this because it says if they're equal. So let's try this again. Okay. So JKL, JK, KL, and JL are all equal. How can we classify this? Well, we can go by sides, and then we can go by angles. So if we go by sides, all the sides are the same, so this gets to be, that's right, equilateral. I think I spelled that right. How can we classify this by angles? Wait, we didn't talk about this. Yeah, we don't really need to for right now. We're going to get into it later. But if we can recognize, maybe we can talk about it as we're here. If the angle is the same, no, I said that backwards. If the side length is the same, that means that the angle across from it will also be the same. So in this case, since all 3 sides are the same, that means that all 3 angles are the same. So we can say this is acute. So we can put this together and we can say this is a equilateral acute triangle. You can even say it's equal this. You can call it that if you want to. I'm going to call it acute. Equiangular. Okay. Alright. XYZ. You know the triangle. I'm not going to draw it though. It's obtuse. What can you say about the types of angles in XYZ? Well, if it's obtuse, we know it has to have one obtuse angle. And then we just talked about it. We said that every triangle has 2 acute angles. Okay, so just by saying what type of triangle it is, we can identify all three angles within that. So this isn't so bad. Alright, pause it again. Classify the triangle by its angle measures. This is not even that difficult. So you have D, B, C. Oh, can we tackle the guy, please? Alright, DBC, which is this one right here. Okay. So if we look at it, we can look at the angles first. We see it has a right angle. So we can say this is a right triangle. Oh, and it just says go by angle. So that's it. So it's right. Oh, it's so boring though. Let's look at the sides too. So we said before, not too long ago, if the angles were the same, right, then the side lengths that are opposite to them will also be the same, right? But in this triangle, we have 70, 20, and 90. So if all the angles are different, that means that all the sides are going to be different too. So this is actually going to be scalene. So right scalene triangle. Okie dokie. Alright, ABD. It's this one over here. So we have 31 and 59. But we can recognize that these two angles right here will make a nice linear pair. So this will be right as well. And again, I guess they're all going to be the same way. Oh well. All the angles are different, so this is going to be scalene as well. And then ADC, the big old thing here. We have a mess that I've drawn. Let's bring it down here. Whoops. So we have an angle of 20 over on the right side, 59 over on the left side, and then this top angle here is going to be 31 plus 70, so that's going to give us 101. So this time, we don't have any right angles. We have two acute angles, but our third angle is obtuse, so the whole thing is obtuse. And they're all different again, so it's also scalene. That's no fun. Whatever. Alright, next three. Classify by the side lengths. Okay, that shouldn't be too hard. So EGH, this time it's starting with the big triangle. We notice that we have these two little tick marks here, which means that these two are the same. And if this is 8, that means this over here has to be 8. And if this short side is 3, that means this over here is 3. So that adds up to 6. So it's not quite equilateral. It's just isosceles. Wait, did I spell that right? I hate triangles. There it is. 2 S's. 3 S's. Yeah. Alright. What can we say about the angles here? At this point, not much. We don't want to assume, and we don't want to get too much into calculating angle measurements from sides right now, so we're just going to leave it as isosceles. Alright, EFH. So EFH is this on the left side here. Ugh, stupid saints. So these aren't very straight lines, whatever. So we have this side here, which is 8, this middle side over here, which is 7.4, and this bottom side, which is 3. So they're all different, and they are scalene. Oh. And what we can say here is if this is an angle bisector, that this and these are congruent, that this should be right angles here. And we'll get more into how this works, so we can also call this a right triangle. And HFG, we can recognize that HEF and HFG are actually the same triangle, so this would also be scalene. This one is also 7.4, 3, and 8. Okay? And the last couple we actually get to write some numbers down, because we haven't actually done any math yet. I guess we added and subtracted a little bit. Whatever. Alright, find lengths of each triangle. So, what we see here is that this and this have one tick mark, which means they have to be the same, which means we can find y by simply saying 6y equals 4y plus 12. So y should be 6, but let's check it just to be sure. Get 2y equals 12. Even though it says 16. 12. So y does equal 6. So we can then substitute it back into our top here. So 6 times 6 is 36. 4 times 6 is 24, plus 12 is also 36. And this side down here would be 36 as well. So we would call this equilateral. Right, over here, same thing, except now we have 3 expressions, but we don't actually need all of them. All we care about are the ones that are congruent to each other, because there's not a whole lot we can do with this right now, because we don't know how this relates to our other 2 sides. The only relationship we know is that this side is congruent to this side over here. So we can say that 2x plus 1.7 equals x plus 2.4. Alright, so we move some stuff around. So if we say minus x minus 1.7, so this will cancel out, this will cancel out, and we'll end up with x equals 0.7. Okay, so 0.7 plus 2.4 is 3.1. 2 times 0.7 is 1.4 plus 1.7 is, guess what, 3.1, because they're equal. And 4 times 0.7 is 2.8, right? Plus 0.5 is 3.3. So we say this is isosceles. Alright, and that's it. So we shouldn't have to spend a lot of time on this on Tuesday, because this is pretty straightforward stuff. So make sure you know how all this works. Oh, and in case you were wondering how the cookie empire is faring, I'll tell you, it fares very well. We're up to like 15 quadrillion cookies up here. So, you know, keeping busy here. They're still not real cookies that I can eat though, but oh well. Alright, enjoy the rest of your weekend. Do some triangle stuff. It'll be fun.